And on that hill on the other side, go this way, until they get right on that line. Now the Romans built these roads straight so they can get to where they want faster. And if you think about it, it's always a good thing. And they built those roads quite well, because some of them still exist in England. And that picture on the right are just some artifacts of what those palm bobs look like. Next up is the water level, which I actually built one last night, and if I can get some help. Let's pour some coffee in here so that we get some color so people can see. Coffee is not a requirement for doing this. All right. I'm going to pour this in slowly, so I try to minimize air bubbles, because that will impact the quality. The thing about water is that always, minus outside forces, like air bubbles, will always level itself out. Always end up perpendicular to gravity. So coffee stayed on one side, but you can see here, get closer. End up at the same elevation. Now, what does this mean you can do? It means you want to build a pad that's level. Someone holds it at one corner. This person goes to the other side, move this up and down until it reads the same on both. You want to build something with a slope. Well, you can calculate what 2% is to make sure water runs off of something, and for that set distance, measure that difference. Do the same thing. I spent $8 on this. It took me about an hour to build. And it's the first time I ever built one. So next time I could probably do it in half the time. I think this is a neat tool. And it can be used anywhere. It's inexpensive. And in reality, you don't need this backdrop. If you have a series of things that you want at the same elevation, you can use just the two. Just pull it out and put one end where you want it to be, and you move the other one to where you want it to be, and it'll eventually settle at the same elevation. Isn't a beer bomb? It is not a beer bomb.
We'll be going back to a college campus.
Well, thank you very much for this opportunity. I hope you learned something, and I am always available for questions if there are any. Again, thank you very much. It's this big. No problem carrying that around. But I would think it matters on a case-by-case basis. And you should never turn down something free.
Just real quick, actually we did that on one of my projects when I was in Portland. And we brought a theodolite down with the tripod or whatever. It was a pain in the ass. And we didn't do anything with it. So I would just I would consider it. Just make sure you need it before you plug it down. But that was one experience.
Is that like a laser level? No. Okay. It's like a total station. No, it's much simpler. Okay.
Total station without the ability to measure distance. Surveying technology has advanced rapidly in the last 40 years. 40 years ago, it was a theodolite and a steel chain, and 3 or 4 guys out doing any type of survey work. Now it's one guy with GPS. So yeah.
Yeah, the GPS isn't good for elevation.
Well, it matters how you use it. There are ways of getting good elevations with GPS, but you have to know exactly what you're doing, or it lies to you very easily, and you'll never know. Question? Yes.
Yeah, that's actually what my question was regarding. Is mentioned Google Earth as a useful tool in surveying, but I was wondering if you had an idea of the precision and accuracy of that tool in measuring elevations.
I got an answer to that. In the United States, NASA did SRTM data, which is the Shuttle Radar Topography Mission. They allow 30-meter resolution in the United States, but in other parts of the world, it's just 90-meter resolution. So most likely, that's the elevation data they've got, unless they've had a private firm and Google's bought better data. And you don't really know what you've got for terrain with Google Earth, but you know for imagery data, the image date, things like that. Terrain, I wouldn't really necessarily pass maybe, I don't know, 200 meters of resolution on Google Earth. You'd have to really supplement that with something else, like SRTM specifically, 90 meter, or actually use some kind of GIS application.
If you're looking for a specific area with, high quality elevation information, there are lots of commercial sources that are not that expensive where you can buy it, where they've gone through and they've done LiDAR type work and developed a 10-meter type grid over certain areas. Especially
Do you
true in
suggest a resource for looking for these applications?
If you've got contacts with a civil engineering firm, my project wasn't civil engineering specific, but we were able to get imagery data from aerial photos through USGS in Honduras that we couldn't have gotten unless we had contacts with the civil engineering firm that could look it up in their databases. So they were able to get us some data that I couldn't have access to, and that Google didn't even have access to. And same with the topography data. Somewhere's out there, someone can just get you the files.